Good evening to all. In this video, we will discuss second normal form. For second normal form, first the relation must be in the first normal form, and we have to check whether is there any partial functional dependency. If it has partial functional dependency, we need to remove. Then only it will be converted into second normal form. So what we need to do? We need to remove the partial functional dependency from the first normal form. Then you will get the second normal form. For this, we are going to see again here. It is in the first normal form. Must be in the first normal form, and no partial functional dependencies. What is the meaning of partial functional dependency? No attribute is dependent on only a portion of the primary key. In the previous video, we understood the partial functional dependency. What is the partial functional dependency? If AB arrow C, it holds the functional dependency, then A arrow B doesn't hold, A arrow C doesn't hold. This is nothing but a full functional dependency. The second normal form must have full functional dependency. That means the relation, if you want to convert into second normal form, you must remove partial functional dependency. Then tell me what is meant by partial functional dependency? Whenever AB arrow C holds, then A arrow B also holds, then there is a partial function A arrow B or A arrow C. So we will consider one example which is going to satisfy the first normal form, and we will remove the partial functional dependency so that we can convert that into second normal form. Consider this example. This example, no doubt it is in the first normal form. How we are saying? Because each cell has atomic values, so it is in the first normal form, not in the second normal form. How we are saying? If this relation, it has partial functional dependency, then we can say that it is not in second normal form. Here it is mentioned first normal form and not in second normal form. Then we need to check whether it has a partial functional dependency or not. So AB arrow C, we will check. AB arrow C. Tell me the values. A1 B1 arrow C1, A1 B2 only one value C2, A2 B1 C1, A2 B2 only one value C2. So AB arrow C holds functional dependency. It is correct. Similarly, you will check B arrow C. For B1, how many values are there? Only one value, that is C1. For B2, how many values are there? B1 C1, B1 C1. That means for B1 only C1. For B2 C2, B2 C2. That means B2 only one value C2. It also holds. Whenever AB arrow C holds, B arrow C holds, then we can say that it is suffering with partial functional dependency. We need to remove the partial functional dependency to convert into second normal form. Then we have only one solution. What is the solution? Decomposition. That means whenever any relation suffering with redundancy or these functional dependencies, partial functional dependency or transfer dependency, the only solution is divide one table into two tables. That is the only solution. So here AB, we have to take it as AB. See the values A1 B1, A1 B2, A2 B1, A2 B2, A1 B1, A1 B2, A2 B1, A2 B2. Then another relation BC, B1 C1, B1 C1. So only one you can take, B1 C1. B2 C2, only one you can take. Here, so AB already primary key. So here also AB is the primary key. Okay. Then here you divided the BC in another table. So what is the common attribute in both the cases? B. So here B is not a primary key. AB is a primary key. So here you can take it as a primary key. Y means for each table you must have one primary key. For a second table you have B is the primary key. For first table AB combined as a primary key. In second table, BC table, if it is the primary key, then this B is a foreign key that references to this table. You know what is meant by foreign key and primary key. Okay. In ER diagram also, conversion of ER into table also we observe these things. Okay. We have to decompose. Then now what happens? Check the first this table. Suppose you can consider as this is table 1, this is table 2, table 3. In table 1 what happens? Unique values are there. There is no partial dependence like A, B, R or C because only two attributes are there. Okay. Similarly here also single values, and there is nothing like partial function dependency. So this is also in 2NF, this is also in 2NF. Okay. And we need to check also, if you combine these two, whether you are getting original table or not. That is nothing but a lossless decomposition. Okay, suppose A1 B1 C1, A1 B1 C1, suppose you consider like this, then what you will get? A1 B1 C1, A1 B2 C2, A1 B2 C2, A1 B2 C2, then A2 B1, A2 B1 C1, A2 B1 C1, then A2 B2 C2, A2 B2 C2, A2 B2 C2. That means here we got the same original relation after combining the decomposite tables. Okay, this is all about the second normal form. In second normal form, the table must be in the first normal form and it must be free from partial functional dependency. Thank you one and all.